All right, for lesson 6.2, we have parallelograms. So what if a college wanted to build two walkways through a parallelogram-shaped courtyard between two buildings? The walkways would be 50 feet and 68 feet long and would be built on the diagonals of the parallelogram. With the fountain where they intersect, where would the fountain be? We're going to look at properties of parallelograms. So a parallelogram is a quadrilateral, so any four-sided polygon, with two pairs of parallel sides. So we have a couple of examples. We have a parallelogram here. We have what we call a rhombus, rectangle, and a square. So naming parallelograms, you will label it A, B, C, D or A, D, C, B, but go in the order around the outside of the parallelogram. That's for how to construct one. So theorems. So opposite angle theorems. If a quadrilateral is a parallelogram, then both pairs of opposite angles are congruent. So B and D would be equal. A and C would be equal. Consecutive angles are supplementary. So X and 180 minus X. So these two would have to add up to 180. And then these two would have to add up to 180. A and D have to add up to 180. And then C and D have to add up to 180. Both pairs of opposite sides are congruent. So AD is congruent to BC, and then the top is congruent to the bottom. And the diagonals bisect each other. So this diagonal AC cuts this one in half, and vice versa. Okay, so there's a couple of proofs that you can look through and practice with. A couple other examples of how to find missing angles. All right, so this one. In here we have opposite angles. So we know that they are consecutive, or not consecutive, congruent. So if V is 115, then the measure of angle X is 115. Here they're next to each other, they're consecutive, they're not on opposite sides, making them consecutive. So they're supplementary. So 180 minus 125, remember they have to add up to 180. And that will give us 55. This one, again, they're not opposites, so they're consecutive. So they're supplementary. 180 minus 60 is 120. And that should be the measure of angle B. Here we have opposite angles. So they are congruent, and measure of angle E will also be 106. If you recall from our properties, opposite sides are also congruent. So opposite sides are congruent. If VW is 9, then UX is also 9. If LK is 17, then MJ is also 17. Opposite sides are equal. All right, so now we have a couple of expressions. So a few examples for you to practice through. And then on this one, so FG, I know is going to be congruent to EH. And then we're going to set up our equation. So X plus 11 is equal to 19. If I subtract 11 to this side, 19 minus 11 is 8, and that gives me X. Again, opposite sides are equal, so AD is going to be congruent to BC. And I have X plus 3 equal to 12. Subtract 3 to isolate X. 12 minus 3 is 9. And then lastly, diagonals bisect each other, so they cut them in half. Again, a few examples for you to look through. So this WU cuts this diagonal in half. So if half of it is 7, then the other half is also 7. And FD, so FD is 40. The entire thing is 40. So then LD is half of that. Half of 40 is 20. Real world application there. And that's it for this lesson.